One type of the cardinality is one-to-one. That means that if you take out an entity of one set of entities and you look at the connection to entities in another entity set, then you could only maintain one of these connections. This is actually expressed here in this graphical notation. You have one entity set E1, which corresponds to this entity set here on the left side. You have another entity set E2, which corresponds to this entity set here on the right side. And in between you have a relationship set here named R, just in general to have a connection modeled between these two entity sets. And you see that in this constellation you have one element from the entity set of E1. One element could be E11, for example. And this element, this entity, has a connection via this relationship set to E2. And here it is a concrete element named E21, which has this relation to E11. And first you look onto this picture in the direction from left to right. So you look onto this direction from E11 to E21. And then to describe the other direction, you look onto E21 and how many connections are allowed from E21 to E11. It's only one. And you see the other elements, E12, E22, E23, E13, all have only one connection to an entity from the other entity set. Only one connection. E13 has one connection, which leads to E23. E12 has one connection to E22. It's important to remark, because with the other cardinalities you have other numbers of connections which are allowed. And you have to look into detail when you describe the different directions. If you want to write up such a situation that an entity from one entity set is allowed to have only one connection to another entity from another entity set, and this other entity should also have at most one connection to an entity from the first entity set, then you have a one-to-one cardinality. And one-to-one is written up in our entity relationship model with two ones here close to the entity sets. And you read it like the following. You read it starting from E1. You just take an entity from the entity set E1 and you describe the relation. There is a relation, and this relation leads to at most one element from the entity set E2. In the other direction you read, well, just take one entity from the entity set E2 and you describe the relation, and the relation is allowed for at most one other entity from the entity set E1. So you saw in the explanation that if you start from this entity set, you don't use this number for the description, you use this number for the description of how many entities are allowed to connect to this first one. And vice versa, You start here without talking about this number. Just say, yeah, there is a relationship to at most one other entity. Be careful when you think about these cardinalities. An example is that you have a car license plate, and a car license plate can be issued to one car, and if you look onto one car, a car has only one license plate number. So this is a one-to-one relationship, a one-to-one cardinality, because a car is assigned one license plate number, and the license plate number cannot be found on two cars, it can only be found on one car. Therefore, we have the one-to-one cardinality here. Now the cardinality 1 to n, or n to 1 if you look into the other direction. If you have a cardinality 1 to n, then on one entity you can have different connections to entities from the other entity set. Vice versa, entities from the other entity set can only be connected to one entity of the first entity set. It's described in the picture here on the right side. Again, you have this entity set E1 and this entity set E2, and here you see that there is an element from E1 which has one connection to an element in E2, another connection to an element in E2, another element in E2, and a third connection to a third element in E2. So this element here actually maintains three different connections. Three different connections to three different entities in the other set of entities. And if you look into the other direction, from E2 to E1, then you see this element here, this entity in E2, has only one connection to the entity in E1. The second element, the second entity in E2, again has only one connection to another element in E1. And the third in E2 also has only one connection to an element in the set of entities E1. So in direction from left to right, you have many connections possible. And in the connections from right to left, you have only one connection which is allowed. And if you look onto the other connections here, then you see it's the same case for all the elements in E2. They have at maximum one connection to an element in E1. Here again, one connection to another element in E1. And the same for this guy here. So, speaking from left to right, we have many connections to this entity set which are possible, and from right to left we have only one connection which is possible to an element from E1. And that's why we write now in our model two different letters, numbers for this cardinality. Now you have to look carefully, more carefully than for one-to-one, onto this cardinalities written up here. For the direction from left to right, we said that we have many connections which are possible to other elements here, and this many is expressed with this n. So we say take out an element from E1 and watch the relationship. The relationship can exist to many of these entities of the entity set E2. Vice versa, take out an element from E2, take out an entity of the entity set E2, and then watch relationship. The relationship can exist only to one entity of the entity set E1. Only to one. And again, pay attention to the described cardinality letter or number. The letter N is important if you come from left to right. And the number 1 is important if you go the way from the right entity set to the left one. Let's look onto an example in the reality. For example, a family. A mother can have many children, and a children has only one mother. That's exactly the situation we can describe with a 1 to n or n to 1 relationship. With the cardinality 1 to n or n to 1. You could imagine here that E1 is the entity set for the mothers, and E2 is the entity set for the children. And as it is written here, one child has exactly one mother. That's a direction from right to left. One child has exactly one mother. There are no other connection to other mothers, usually. So one child only has one mother. In the other direction, one mother can have many children. That's what is written here. One mother can have many children. Many children belong to this mother here. And therefore, in this case, mother to children, we have to choose the 1 to n relationship, if you say it from left to right, or n to 1 if you describe it starting with the side of the children. One to 1, 1 to n, and now n to m. Many to many. N stands for many and m stands for many as well. So in this case now, in both directions, we have the possibility to maintain for each entity many connections to other entities from the other entity set. This is shown here again in the picture. Entity set E1, there's a connection, there's an entity which maintains two connections to two different entities in the entity set E2. And if you look into the other entities in E2, then this entity as well maintains two connections to the first one in E1 and the other one in E1. So both sides, both entities maintain many connections to entities from the other side. And that's why we have a m to n cardinality here, a constellation with many to many relationships. If you want to write up this cardinality, then we just write n and m here beside the entity sets. And again, we have to read it carefully. Just take an element from E1 and describe the relationship to many entities in E2. There are relationships possible to many entities in E2. Vice versa, if you take out an entity from E2, you can have a relationship again to many entities from the entity set E1. So in both directions, many other of the entities are possible to connect. Many other entities are possible to connect. Even though it's symmetric, look at the cardinalities carefully so that you don't mix it up with 1 to n, or n to 1. Again, there's an example. The example is based on the model we discussed before. We have students and professors somehow examine or teach students. So a professor teaches many students, and a student is not only taught by one professor, but by many professors. So we have exactly this n to m constellation here. One professor teaches many students, and one student attends not only the lecture of one professor, but the lecture of many professors. So you could imagine that the entity sets here are the professors. Professors teach many students, this one and this guy here, and this student here doesn't listen only to this professor in the lecture, he listens also to the lecture of the other professor. So cardinality m to n, here in this example professor to student.